Introductory Stream Health series. We're here to learn about sediment and why it's PA's #1 surface water pollutant. Please feel free to type questions into the chat box at any time during the presentation. Riley, my coworker, will be monitoring the chat box and will compile questions for the end of the presentation. We'll follow up with resource links, and if someone has a question that we are unable to answer, I will do my best to include resources to address it in the follow-up. Please also look for a brief survey at the end of the entire series in late June. Your responses will really help us to create future content that is useful to you. These webinars are being recorded and will be available on our website for future use. My name is Rebecca, and I work in the watershed program here at the Allegheny County Conservation District. In a usual year, you will find me planting and tending riparian buffers, which is the strip of vegetation that runs alongside a waterway, and working with watershed groups. Today's webinar is Chapter 3, all about sediment. If you haven't registered for the remaining chapters and would like to do so, you still can, and we would be happy to have you. You can find registration info on Facebook and on our website. Before diving into Chapter 3, here's a quick review of our previous chapters. We defined what a watershed is and all the parts of the stream system, including bed and banks, floodplains, and riparian areas. We discussed that streams are dynamic systems that are always changing. Outside bends typically undergo erosion because the flow is faster, and inside bends act as areas for sediment to deposit. There are physical, chemical, and biological factors that all need to be assessed to fully understand the health of a stream. And the stream is a system. Everything ties together and influences the overall health of the system. These chapters build on one another, so I may talk further on some of the content that Amy covered because it is especially relevant to our topic today, but I am assuming you tuned into the webinars before and have a baseline understanding of topics already covered that are incorporated into this chapter. As a reminder, if you're just joining us, please feel free to enter questions into the chat box and we'll address them at the end. This presentation will cover introductory info on sediment and erosion, natural processes, and accelerated processes. I want to emphasize that this presentation, like all others in the Stream Health series, is not the whole story, but a brief overview for folks to learn about in basic important concepts relating to sediment. There are many things relating to sediment that will not be covered, and the topics that are covered are just the tip of the iceberg. So, sediment is the #1 waterway pollutant across the entire United States. We will begin the story, as most stories relating to environmental issues begin, before the dawn of us humans. To talk about sediment, we have to talk about erosion. In a stream system, the velocity or speed of the water acts like sandpaper, which breaks down and transports the surface of the stream bed and banks. Water carries sediment along with it, which aids in further breaking down material. This photo is an example of stream bank erosion here in Allegheny County, and I'm sure many of you have seen countless stream banks like this. So, the process of erosion can both break up sediment from a source, like a stream bank, and transport it. Sediment itself is natural stuff that is broken down. Soil, rocks, plants. Sediment can range in size from larger rocks to sand, silt, and clay. Let's look at some world-famous examples of erosion. The Grand Canyon was not always a canyon, but a plateau, which means a generally flat landscape. The Grand Canyon has been gradually eroded over many years by the Colorado River and other streams that drain into the Colorado River. This is erosion in action, and this process has been gradually transporting sediment downstream. Another world-famous example of erosion, our very own Three Rivers. Eons ago, Western PA was flat. We can credit our rolling hills and valleys mostly to water. Streams and rivers cut through and erode, 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 which has given us our present day landscape. We've looked at the definitions of sediment and erosion, which sets the stage for talking about how they work within a system. Sediment and erosion are natural parts of the cycle and structure of all water bodies. They are essential for the never-ending cycle of breaking down and building up a system, and is part of the habitat and food web for aquatic and land creatures. In a natural system, erosion is an important part of the life of a stream. If you tuned into our earlier webinar, you already learned that water travels more quickly on the outside bed of a stream or river and slows down on the inside bed, allowing sub-sediment to drop out and build up. In this ongoing process of inputs and travel, the system is always changing and accommodating what is coming downstream. You can see in this diagram, sediment is traveling from upstream, cutting into the banks, and depositing. Also notice that the stream is meandering over time, which is largely driven by the process of erosion and deposition. The things that influence how much sediment is being transported and at what speed include how much sediment there is and the sizes of sediment, as well as how much water is coming through, plus the slope of the stream channel. Think of a stream raging after a storm. It has more power to move more stuff at that time. Here's essentially the same diagram shown in the last slide, but with a bird's eye view. It is worth emphasizing the earlier lesson here that within a natural system, stream and landscape system, there are floodplains. The duty of the floodplain is in the name, they flood. Flooding is natural. During a heavy rain or snowmelt, the increased flow and sediment traveling along with it will sprawl out into the floodplain, slow down, drop some sediment, and continue flowing downstream, but in a more paced way because it's had room to sprawl out and slow down. This photo is an example of the stream using its floodplain. Notice how muddy that water is with sediment particles. After the increased flow has made its way through, the flow will return back to its usual channel size. Because this is an intro chapter, I want to make sure that we are all on the same page in understanding the importance of vegetation in stabilizing the landscape and how it links to the problems we have today. Any soil that is not protected from rainfall may be eroded. As you can see in this tabletop experiment, the cleanest water drained through the vegetated pop bottle. The middle bottle had some ground cover, which helped to interrupt and slowly drain the water, and the dirtiest water is the bare soil. Water was added and it went straight through, take everything it could with it. Vegetation, especially native vegetation, holds soil in place, increases storage room for water, slows down direct precipitation, and slows down runoff. A closer look at the role of vegetation in the natural environment. Trees are stormwater infrastructure. Runoff is slowed, stored, and filtered. Roots hold soil in place. Look closely at the plants diagram. You will notice that regular grass, which makes up millions of acres of land in the US, has a very short root system. Deeper roots provide two important tasks. They are better able to hold soil in place, and they increase the storage space for water in the ground. Turf grass does not offer that much more than paved surfaces do in terms of slowing and absorbing runoff and keeping soil in place. For in-stream erosion, the same important functions once more. This is a riparian or streamside buffer. It reduces erosion by keeping soil in place, slows runoff, and helps to filter pollutants. Well, if sediment and erosion are natural parts of a system, why is sediment the #1 surface water pollutant across the entire US? There's so much more of it without the natural systems in place that would normally manage it. Not only is our human influenced landscape the generator of accelerated erosion and sediment, but it also magnifies the problem. There is more runoff, more sediment, and more erosion. We remove floodplains, channelize streams, or pipe them all together. We have built next to streams and removed or reduced the natural processes that would have helped to manage the increase in all of these inputs. As icing on the cake, we have extra challenging terrain here in Western PA. It's steep hills and valleys, which allows for runoff to pick up much more speed and power compared to a flatter area. Clay soils are another factor. Clay soil does not absorb as much water as other soil types. Steep slopes, altered streams, vegetation's been replaced with buildings, parking lots, and roads. Stormwater, the perfect storm. There is a lot of sediment. It is the #1 pollutant, and it impacts many, many things. Properties, drinking water quality, habitat for aquatic life and life on land, long and short-term pollution, and infrastructure. The main sources of sediment in developed environments include in-stream erosion due to unvegetated banks or other changes, construction activities, developed areas generally. Think of all the gravel and buildup you see on roads, or perhaps from a neighbor's garage expansion, and agriculture. Remember, all bare soil is a candidate for erosion. Here's some EPA fun facts. Human land activities are responsible for 70% of erosion, and the most concentrated releases are from construction activities, even from small stuff like home improvement projects. And it all racks up to around $16 billion a year in damages, like infrastructure maintenance, lost agricultural productivity, lost recreational opportunities, and increased drinking water treatment costs. Earth disturbance activities are regulated for a reason. Erosion and sediment control is the bread and butter of a conservation district. The district reviews plans for construction activities disturbing an acre or more for proper best management practices, like these pictured here, and follow up with inspections and respond to complaints. You may have seen BMPs like this in the area, and if not, maybe you will recognize them. Silt socks, silt fencing, and mulching are all common BMPs that are designed to slow and filter runoff on the site. I love walking in my neighborhood, especially since it's been pretty slim pickings on entertainment options these past few months. And these are shots of sediment sources just over the past couple of weeks, and I could have taken 100 more. The photo on the left is a pile of gravel and dirt left after work was completed on this utility pole. The center photo is a lawn project. You can see visible signs of runoff from this bare soil on the sidewalk. And the photo on the right is one of many bountiful piles of gravel and dirt on the roads in my neighborhood. I don't live near a stream, so the sediment sources in my neighborhood can travel to a local waterway via wind or by stormwater runoff into a storm drain, which will then outlet to a local stream. These little patches of sediment certainly add up. Okay, we review some of the biggest sources of sediment and erosion in a developed area. Now let's move on to greater pollutant concerns associated with sediment. In a developed environment, sediment is no longer just an innocent batch of worn down rocks. It can bind and transport to really harmful stuff, which then gets carried into waterways through stormwater discharges, wind, and overland runoff. This is problematic, both in the short term and the long term. Certain pollutants can stick around in the beds of waterways for years and years. All living things depend on the quality of the natural environment, including us humans. Consider our drinking water. Streams, rivers, reservoirs, they serve as our drinking water sources. Water treatment plants draw directly from these sources. Sediment and the pollution it travels with impacts life in the stream. It fills in the habitat provided in the stream bed and along the banks. It smothers eggs and clogs gills. It increases the temperature of the water and the amount of oxygen available for life in the stream. It disrupts the food chain, and it can both block plant growth and stimulate a bad kind of plant growth, which further magnifies the problem of a lack of food and habitat. Okay, in an undisturbed stream system, there are different sizes of rocks and cobble, branches, leaves, overhanging roots. All of the different sizes and materials provide habitat, places to find food, and places for aquatic critters to lay eggs. Sedimentation both overruns all of that needed diversity and physically blocks spaces for very important functions like egg laying, which continue the survival of the species that live in the stream. This is an impacted stream in Allegheny County, and it is highly embedded. It provides poor habitat and opportunities for aquatic life that would normally live in this area to thrive. This stream is actually filled with a lot of material from the dirt and gravel road that is essentially the same height as the stream. I highly recommend tuning into this Thursday's webinar chapter on infrastructure and water quality to learn more about these types of impacts. As we learned, sediment can range in size from very, very fine to silt to boulder size. Smaller sediment can clog the gills of fish and lowers the available dissolved oxygen. I have many personal experiences of being in a smoky room or bar and feeling so uncomfortable from a lack of clean air that I had to leave. And maybe in-stream creatures experience something close to that, what a smoky room is for us. Another consequence of sedimentation is nutrient loading, which can promote wild algal growth, another negative impact to aquatic life in terms of clogging habitat and making it difficult to navigate and find food. Excessive algal growth is a useful tool to identify potential nutrient loading for monitoring streams. We'll be discussing nutrients in greater detail in Chapter 5 of this webinar series next week. Sediment messes with stuff we use too. It damages stormwater infrastructure, roads and bridges, and can cause flooding. Sediment can overwhelm infrastructure, including bridges and the systems that manage stormwater. It isn't hard to imagine this stormwater inlet pictured in the middle holding up flow during a storm and overtopping the banks of the stream to flood the street, or the photo on the right causing street level flooding nowhere near a stream. Stream bank erosion is a big source of sediment. I ask that the next time you are out and about, you look at the streams as you pass by and take notice of how the land around them is being managed. You will find streams that are mowed right up to the bank, streams that are overrun with invasive species like Japanese knotweed, and streams that are right next to roads or buildings that do not leave much option for anything. Planting trees and shrubs is a really easy way to help reduce erosion and stormwater runoff. So in this photo, I'm asking, where are the big roots of trees helping to hold these banks in place? Where is the vegetation help slow and filter runoff? Notice also in this photo the amount of fine sediment material that is jamming up the stream bed. Last, but certainly not least, are drinking water, and I threw in recreation and navigation in there as a mention. Drinking water costs increase as turbidity increases, and increased sedimentation impacts recreation, including fishing, kayaking, and boating because of increased blockages in channels and overabundant algal growth. Sediment is bad for drinking water quality, which means it's also bad for our wallets. Numerous studies point to the increased cost of treating more turbid water, and numerous studies can also strongly link that removal in forest cover increases sediment loading. For the citizen scientist in you, Amy covered the basics of monitoring and assessment in the previous webinar, but here's a little refresher. Turbidity and total suspended solids measure different things, but these both test particles in the water column. There are different methods for each of these tests. Some are more expensive or elaborate than others. And then we have visual observations. Keeping an eye on common indicators of overabundant sedimentation, including algal growth, a lot of fine sediment in the stream bed, or a lack of diverse sizes of sediment and woody stuff. Here are a few things you can immediately and in the short term do to help reduce sedimentation in our rivers and streams. Share what you know. If you didn't know before, today you do. Sediment is a pollutant and there are clear sources and causes. If you're a property owner, are there things you can consider changing to help reduce sediment from running off your property? Planting trees and shrubs, mowing less overall, putting in a rain garden or a swale, and cutting back or eliminating pesticides and fertilizers because they travel with sediment into our waterways. Be sure to cover up any bare soil projects with mulch or a tarp if the area will be exposed for more than just a day of activity, especially if it's expected to rain. Observe and report. Construction sites should have things like silt fences and silt socks in working order. If you notice that these BMPs, best management practices, are in poor shape, and that there is consistent muddy sediment runoff, call our office. Please keep in mind that heavy rainfalls have an impact and things might fail after a heavy rain, no matter how effectively the BMP was installed. Give time for things to be back in order if there is a failure. One of my favorite topics and activities, riparian buffers. It is my belief that as a streamside property owner, you have a great responsibility. Mowing up to the stream is harmful in more ways than what we discussed here. Consider at the very least leaving a strip of meadow that is mowed only a handful of times a year. The ideal is planting native trees and shrubs as far as wide as of a margin as you can or are willing to do. Adopt a drain. This is my adopted drain in the photo, jammed with sediment. It is cleaned up. I do regularly keep an eye on this thing to keep it clean so it doesn't pile up with sediment, and I'm keeping that sediment out of the storm sewer system in the first place. Take-home messages. Any bare soil is a candidate for erosion. Sediment impacts many things, including life in the stream, drinking water quality, and infrastructure. Native vegetation and green infrastructure, like rain gardens and grassed swales, will help us to reduce sedimentation. Oh, I think Here it is. An ounce of prevention is worth a pound of cure. Money and effort upfront saves us from spending much more money and effort down the line. Thanks very much for listening, and I will take any questions if there are any to answer.
Thanks, Rebecca, for all that awesome information. We did have one question in the chat box during the presentation. The question is, what are the best native non-woody vegetation to plant on stream banks for construction projects, both from a stream bank protection perspective and successful growth perspective?
I can follow up with resources so I don't have to rack my brain and give rushed answers. So non-woody vegetation, there are so many resources out there that outline planting types, location, budget, all of that. So I'll follow up with those in the email.
Great, thanks for that. I'm not seeing any other questions in the chat box right now. If anyone would like to contribute a question, feel free to throw that in the chat box now. Otherwise, oh, here we go, here's a question. Are businesses required to use a particular mix of grasses for restoration?
There is a standard mix if you're completing a permitted project, but as far as just a business or property owner revegetating a bank, there are no requirements.
We have another question here. If I notice a storm drain needing a clean out, who do I notify?
It depends on where you live. I live in the city of Pittsburgh, and I can actually tweet at Pittsburgh Water and Sewer Authority to say there's a blockage or a failure. So whoever is the owner operator of your sewer system, if you're likely it's a municipality, or I think that'd probably be the first place that I would go. if you can't take care of it yourself. I just get in there with a shovel. But for more elaborate things, you want to contact your municipality or sewer authority.
We have a question here from someone who missed our first presentations. And just as a reminder, this webinar is being recorded as well as our previous and future webinars, and we are going to have those available through the ACCD website at the end of this series. We have another question here. Do you have a recommendation for how far back from the edge of an eroding bank to plant new woody riparian species?
It depends on how much money you're willing to put in and risk. We recommend planting cheaper things like willow stakes right in the channel because it's a smaller investment money-wise if they happen to get wiped away. But if we're planting trees we put some money into, we'll set it back from the top of the bank, maybe 5 to 10 feet, to give a little bit of time for the trees and shrubs to really develop their root system so they can hold their own if flood waters come through.
Thanks for that. And that looks like that is the last of the questions.
Great. Well, thank you so much for listening today. Feel free to follow up with any more questions, and we hope to see you for the remaining chapters in this webinar series. Everybody enjoy the hot summer day.